Hello guys, today we'll be studying ellipse. This is a part of coordinate geometry. We'll be covering the basic concept of the chapter ellipse. Along with that, we will also cover previous year questions which will be solved from basics. So if you have no clue about ellipse, this is going to be sufficient practice for you. Okay, let's begin with the basic concept. Let's try to understand what is a conic section. Conic section basically means it is the locus of a point such that PS upon PM is equal to E. What is PS? PS is distance of a point from focus. What is PM? Distance of that point from directrix. So distance of a point from focus upon distance of that point from directrix is equal to E. That is a constant known as eccentricity. We have covered in the chapter parabola that for parabola eccentricity is 1. Now we have to study ellipse. For ellipse, eccentricity is less than 1. That implies PS upon PM is less than 1. So we can say that PS is less than PM, that is the point is closer to focus than it is to directrix. This is the basic definition of ellipse. Now let's move forward to the basic equation of ellipse. This is the standard shape of ellipse if the center is at origin and the major axis is of A length, minor axis is of length B. Then the equation is written as x square upon a square plus y square upon b square equals to 1. This equation represents this ellipse. And now we have to talk about certain important points. There are going to be two focus. First focus is going to be AE comma 0. Second focus will be minus AE comma 0. Directrix is going to be at x is equal to A upon E. Another directrix will be at minus A upon. Okay, I hope basic was clear. Basic equation and these terms. Now let's move forward to a different kind of parabola. Different kind of ellipse. A vertical kind of ellipse. Let's say the center is at 0, 0. Then we have to write this is the major axis B. This is the minor axis A. Then the equation will be x square by a square plus y square by b square equals to 1. Now let's talk about the important points. That is focus, which will be at 0, BE. Another focus will be at 0, minus BE. Directrix is going to lie at y equals to b upon E. Another directrix will be at y equals to minus b upon E. Okay. These were the some basic terms. I hope you have covered the chapter parabola. So you will be knowing this is known as axis since it is the longer side. So this is the major axis. This is the shorter side. So this is the minor axis. In the second example, this is the longer side. So this is the major axis. This is the shorter side. So this is the minor axis. Okay, now let's talk about eccentricity of the curves. Eccentricity is under root 1 minus put the smaller thing upon the bigger thing. So for this ellipse, this is the formula for eccentricity. For this ellipse, eccentricity will be under root 1 minus smaller is A, so it will be A square by B square. Always remember, you have to put smaller upon bigger, smaller upon bigger. So for different ellipse, the formula is going to change. Now the last important formula is latus rectum, which is 2b square upon A, small upon big. Latus rectum will be 2a square upon B, small upon big. If you remember these formulas, it will be sufficient for you to solve all the questions. Okay guys. Okay, now let's try to understand what is the question saying. The distance between the foci of an ellipse is 16. So if this is my ellipse, the distance between foci is given as 16 and eccentricity is half. So eccentricity is half. We have to find the length of major axis. It is a simple question for someone who remembers the formulas. As I said, this distance is AE. So this distance will also be AE. So I can say this total distance will be 2AE, which is equal to 16. So I'll write 2AE equals to 16. AE equals to 8. Now put the value of E, half over here. A into half is equal to 8. So A is equal to 16. And we know A is this length, which is 16. This length is also A, 16. 16 plus 16 is going to be 32. That will be the length of major axis. Okay, now let's proceed on towards the next question. In an ellipse, the equation is given. So I'll write it in standard form. 9x square plus 5y square equals 45. Bring this 45 down. I'll get 9x square upon 45 plus 5y square upon 45 equals to 1. So this becomes x square by 5 plus y square by 9 equals to 1. So this is the standard equation. It is asking distance between foci. So as we can see, y coordinate is bigger. So it is going to be a vertical ellipse. In case of vertical ellipse, the distance between foci is written as twice of BE. I have B, I require E. So I have to calculate eccentricity. We remember the formula 1 minus small ka square upon big's square. So it will be under root 1 minus small is 5, big is 9. So it becomes under root 9 minus 5 whole by 9. It is going to be 2 by 3. So I have eccentricity. So we have to find distance between foci. Distance between foci is 2 into B into E. 2 into what is B? B is 9. So I'll write down 9 ka under root. Then E is equal to 2 by 3. Root 9 cancels 3. I'll get 4, which is the answer to this question. Now let's proceed to the next question, which is asking eccentricity of an ellipse if lattice rectum is half of minor axis. So in this case, I'm assuming the ellipse to be horizontal. You can assume it to be vertical. The answer is going to be same. In this case, I'm assuming it to be horizontal. The lattice rectum is half of minor axis. So as we can see, lattice rectum is 2 into B square upon A is equal to half. Minor axis is 2 into B. 2 cancels 2, B cancels square. So I'll be left with 2B equals to A. Now 2B equals to A. We have to find eccentricity. The formula for eccentricity is 1 minus small square upon big square. A is equal to 2B. So A square will be 4B square. So putting that value over here, I'll get 1 minus B square upon 4B square. B square cancels B square. I'll get under root 1 minus 1 by 4. That is root 3 by 2. So eccentricity is going to be root 3 by 2. Okay guys, let's proceed with the next question. The curve represented by this equation, is it a parabola, a pair of straight line, an ellipse with this eccentricity, or another ellipse with a different eccentricity? As you can observe, this is not a parabola. Since x is also squared, y is also squared, and you can observe there is a plus in between, so it cannot be hyperbola. It has to be an ellipse. So we can see it is either C or D. Now we have a differentiating factor, that is eccentricity. I'll teach you a short trick. A short trick to find the answer. Eccentricity of ellipse is always under root 1 minus coefficient of x square and coefficient of y square. Put the smaller one upon the bigger one. That is the answer. So if I solve it, it is going to come as root 3 by 2. So the answer is going to be D. I'll revise the short trick. The short trick says eccentricity is under root of 1 minus, compare the coefficients. Coefficient of x square is 4, coefficient of y square is 16. Put small upon big. So this becomes under root 3 by 2. That is the answer. Okay, now this is a question for you to practice. Pause the video. Try the short trick for yourself. I hope you have paused the video and tried it yourself. Now I'll let you know the answer. The eccentricity of this ellipse. Eccentricity is under root 1 minus 25 and 16. Put small upon big. So this is going to be 25 minus 16 by 25 whole under root. That will be 3 by 5. So answer is going to be D. I hope you all would have solved it correctly. Okay, now we have to proceed with this question. We have to find the eccentricity of an ellipse whose major axis is 3 times the minor axis. So let's assume the ellipse is horizontal one. You can even assume it to be vertical one. The answer is always going to be the same. Now the question says major axis is 3 times the minor axis. Major axis is 2a, which is equal to 3 times minor axis, that is 2b. 2 cancels 2. I'll get a is equal to 3b. Now we have to find eccentricity. Eccentricity says under root 1 minus small square upon big square. A square is going to be 9b square. Putting that value over here, b square cancels b square. I'll get 1 minus 1 upon 9, that is 8 upon 9's under root. It will be 2 root 2 by 3. That is going to be the eccentricity. So, focusing at this question, if the latest rectum of an ellipse is equal to half of its minor axis. So the question says latest rectum is half of minor axis. I'm assuming it to be a horizontal ellipse. So half of minor axis, what is the eccentricity? Latest rectum is 2, b square upon a. It is equal to half of 2 into b. 2 say cancels half. Then I'll get b cancels square. So 2b is equal to a, squaring both sides. 4b square equals to a square is the relation. We have to find eccentricity, which is under root 1 minus small square upon big square. A square is equal to 4b square. Now b square cancels b square. I'll get under root 1 minus 1 by 4. That is equal to root 3 by 2, which is going to be the final answer. Okay. So now let's focus at this question. What is the eccentricity of this ellipse? Please pause the video and try it for yourself. It's a very simple question. I hope you would have tried it for yourself. Now let's have a look at the solution, which says taking 144 in the denominator, I'll get 4x square by 144 plus 9y square by 144 equals to 1. 4 cancels this. I will get 36. 9 ones are 9 and 54 16. So I'll get 16 over here. This is 6 square, this is 4 square. Eccentricity is 1 minus small one, that is 16. Big one is 36. 36 minus 16 is 20 by 36. 4 5s are 4 9s are. So answer will be root 5 by 3. I hope you would have solved it correctly. Moving forward to the next question. In an ellipse, length of minor axis is 8. That means 2b is equal to 8. Eccentricity is root 5 by 3. So e square is equal to 5 by 9. So I can say formula of e is under root 1 minus b square by a square. Squaring both sides, I'll get e square equals to a square minus b square upon a square. This goes over there. So I'll get a square e square equals to a square minus b square. So now I have minor axis. I have to find the major axis. Okay. Now using the values which I already have, I have b equals to 4. So I'll put that value. 4 square is 16. I have e square, which is 5 by 9. I'll put 5 by 9 over here. Great. So I'm having 5a square equals to 9a square minus 144. Taking this over there and this over here, I will get 144 equals to 4a square. A square is equal to 144 by 4, that is equal to 36. So a is equal to 6 and major axis is 2a, that is going to be 12. So that is going to be my answer. This was a question that required 2 different concepts. If you found it confusing, please rewind and watch it again. This type of question can be asked in your examination. Okay, let's read this question, which says the foci of an ellipse are given. So x coordinate is given, y coordinate is 0. That means they lie on the x-axis. So on x-axis, first focus is 4, 0. Another focus is minus 4, 0. So the ellipse would look something like this. Center will be at 0, 0, and these are the 2 focus. Okay, this length is 4, and as we have memorized, focus is at a distance of AE. I'll choose a different color. Focus is at a distance AE, so I can say AE equals to 4. Question has given eccentricity as 1 by 3. Put this value over here. A into 1 by 3 is equal to 4, so A is equal to 12. Now, okay, so I've completed the question. We have to find the equation of ellipse. If I have A, to find the equation I also require B. I will use the formula of eccentricity to find that. We know that eccentricity is under root 1 minus b square by a square. Putting the values, e is equal to 1 by 3 under root 1 minus b square. A square is going to be 144. So now if I have a square, squaring both the sides, I'll get 1 by 9 is equal to 1 minus b square by 144. So this implies 1 by 9 equals 144 minus b square upon 144. Cancel with 9, I'll get 16. So I'll get 144 minus b square equals to 16. Taking this over here, b square is 144 minus 16, that is equal to 134 में से 6 गया 128. Okay guys, so we have calculated a, that is 12. So a square is equal to 144, b square is 128. So the equation of ellipse is going to be x square upon a square, that is 144, plus y square upon b square, that is 128, equals to 1. This is going to be our final answer. Okay, let's focus at this question. The distance between foci of an ellipse is 8. So this is the ellipse. These are the two foci. This distance is AE, this distance is AE. So the total distance between the foci is twice of AE. So now I'll say twice of AE is equal to 8. So AE is equal to 4. This is the first condition. And distance between directrices is 18. Oh, this is a new concept. These are the two directrices. Directrix is at a distance of A by E. So I can say this distance is A upon E. This distance is also A upon E. So the total distance is going to be twice of A upon E. So I'm going to write it like this. Twice of A upon E is equal to 18. So I'll say A upon E is equal to 9. If I multiply these two results, on multiplying them, if I multiply them, I'll get AE into A upon E, which is equal to 36. E cancels E. We get A square is 36. That implies A is equal to 6. Now we have to find the equation. So for that we also require B. We will calculate B by using eccentricity. Okay guys. So now A is equal to 6. Put this value over here. 6 into E is equal to 4. So E is equal to 4 by 6. E is equal to 2 by 3. We have eccentricity. Now we'll use this formula. E is under root 1 minus b square by a square. On squaring both sides, I'll get e square equals 1 minus b square by a square. Taking this over here, taking LCM, what will I get? E square equals a square minus b square upon a square. Taking this over here, I'll get a square e square equals to a square minus b square. And I'm writing over here a square e square equals to a square minus b square. Putting the values, AE is 4. AE is 4 square 16. A square is 36 from here minus b square. So b square taking it to LHS, 16 taking it to RHS. B square is 36 minus 16, which is equal to 20. So I'll get the value b square as well. So the equation will be x square upon a square plus y square upon b square equals to 1, which is going to be the final answer. Okay guys, let's focus at a small topic. We have studied that if an ellipse looks like this, center is at 0, 0. Equation is x square by a square plus y square upon b square equals to 1. I'll make a teeny tiny change. Ignore this equation. Now the center is going to be present at h comma k. Then the equation becomes x minus h whole square upon a square plus y minus k whole square upon b square equals to 1. This is the equation of ellipse. This is the teeny tiny change. Now let's practice a question on this topic. So now this is going to be some ellipse and its center is going to be h comma k. I'll teach you a shortcut to solve such questions. The shortcut says differentiate with respect to x. D by dx of this equation is equal to 16x plus 0 minus 16 plus 0 plus 0. These are treated as constants. So I'll get 3 zeros is equal to 0. So I'll get 16x minus 16 equals to 0. Taking this over here, 16x equals 16. Hence x is equal to 1. So I get the equation x equals to 1. Then in the same equation, now calculate d by dy and put it equal to 0. So 8x square is 0, 6y square becomes 12y, 16x becomes 0, 12y becomes plus 12, 13 becomes 0 equals to 0. So now I'll say 12y plus 12 equals to 0. So y plus 1 equals to 0, y equals to minus 1. I'm getting 2 points, x is 1, y is minus 1. This is going to be the answer. Okay guys, now we have to find the foci of this ellipse. First let's simplify by bringing 48 in the denominator. This becomes 3x square by 48 plus 4y square by 48 equals to 1. So I'll get x square by 16 plus y square by 12 equals to 1. Now we need, for foci we know the formula is AE. We have A as 4, A is equal to 4. Now we require E. If I have to calculate E, I'll use the formula under root 1 minus B square by A square. So it's going to be under root 1 minus B square is 12, A square is 16. So on simplifying, I'll get 4 by 16. That is 1 by 2. Now I have eccentricity 1 by 2. A is 4, E is 1 by 2. So AE is equal to 2. Now I have AE as 2. From this equation we know center is at 0 comma 0. So in this ellipse the foci is going to be at a distance of 2 on right hand side. A distance of 2 on right hand side will be a distance of 2 on x axis, that will be 2 comma 0, and a distance of 2 on left hand side, that will be on negative x axis, so it will be minus 2 comma 0. So the answer is going to be plus minus 2 comma 0. So this was the basic concept of ellipse and previous year questions and some important questions and concepts which will help you in your final IMU CET paper. Thank you for watching.